Hello, everybody. Let me make sure this is plugged in. My dog was just underneath me. Oh, she unplugged it a little bit. I'm glad I checked that because I didn't want to record that and have it all screw up because it falls out. Okay, so we are on page 37 today. We're talking about nope, we're on page 36, sorry. We're talking about volumes of spheres. Let me flip over to that for you. There it is, volumes of spheres, page 36. Volumes of spheres is pretty easy. Compared to what we've been doing, volumes of spheres is a piece of cake. So let's just jump right into it. A sphere is a geometric solid in which every single point on the side of the solid is equidistant from the center point. Kind of like a circle, right? A circle is a two-dimensional shape in which here's your center, all these points around it are equidistant away. It's the same idea, just in three-dimensional space. So this is kind of what it would look like. You can't really see my dotted line in the back. It kind of got faded a little bit, but it looks like this in the back. There we go. So a few things to be mindful of. Obviously, we still have a diameter. It's the line that goes all the way from one side to the other through the center. We still have a radius that starts at the center and goes to any spot on the sphere, now three-dimensional, kind of like a circle and any spot on the circle, but now it's three-dimensional, it can go anywhere. There's also a couple other important vocab words. The first one is around the center of the sphere, around the middle of the sphere, there's a circle called the great circle. The reason that we say that is because if you think about a sphere, really there's a tiny little circle on top, and then a bigger circle, 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 and the circles just keep getting bigger and bigger and bigger and bigger and bigger, and they get to the center, and they get smaller and smaller and smaller and smaller and smaller until they get to the end. We call that biggest circle the great circle, and you guys have learned about a great circle before, probably in geography, right? If you think about the planet, we have a sphere for a planet, unless you are a flat earther, in which case, go away from me. Just stop now. Just give up. I'm sorry. But we have a planet that we live on that is a sphere. And that sphere has a line right through the middle that we refer to as the equator, right? The equator is the center line of the Earth where everything's the hottest because it's closest to the sun usually, all that stuff. So the great circle is the equator of the sphere. And if you take that great circle and cut it, you have two halves of the sphere, and we call those hemispheres, just like we have a northern and southern hemisphere on the globe. You have hemispheres. That's what makes up halves of spheres. So with that, we have our formula as well. Mouse, where are you? I don't know why it's stuck on the bottom. Oh, because my pen. Okay. There we go. So you have a formula for the volume, and I wrote it in two ways. The volume formula is 4/3 pi r cubed, which if you're not sure how to put that 4/3 in your calculator and that part's confusing, you could just type 4 times pi times r cubed and then divide by 3 at the end. So that's the formula. It's just you multiply and then divide by 3 at the end. So here is our first example. I got 3 examples to look at today. The first one is find the volume of this sphere, and then it says round to the nearest hundredth, which I cut off because I didn't feel like copying and pasting twice. So we want to find the volume of the sphere. Well, the important piece is that we know what the radius is. In this case, nice and easy. We know the radius is 7 inches. They already gave us the radius. Really easy to use. So we're just going to take the volume formula, 4/3 pi r cubed. So in this case, pi 7 cubed. And we're going to work this out. So the first thing I always find is what 7 cubed is. By the way, this also said use... No, it didn't. Never mind. Sorry. We find out what 7 cubed is. So to do that, I put 7 times 7 times 7 in my calculator, or if you have a cube button, you can put 7 to the cube power. You all probably have a cubed button in your calculator, just sometimes they're hard to find. But if you do that right, you'll get 343. Well, at this point, you can put this into your calculator. So what you can do is 343 times 4. And if you do 343 times 4, you're going to get 1,372. And at this point, everything can be put in the calculator. Take 1,372, multiply it by pi, divide that by 3, and we get that the volume is 1,436.76. And we're talking in inches, so we're going to put inches cubed. Again, I rounded it to the hundredth, so I don't remember what it gave us exactly. It might have been 0.75 something or 0.76 something, but make sure you round it to the hundredth, and that's what it would look like. Going over here so you can see the nicer version than what I wrote. This all kind of got cut off a little bit. It gets a little bit blurry here, so I'll do my best. That doesn't look too bad. I think you can see that pretty well. All right, the second example asked us to find the volume in exact form, the exact volume. So the first thing I got to determine is what is the radius. Well, you can see that all the way across is 18 feet. Well, that's the diameter. If the diameter is 18 feet, then the radius must be half of that, so 9 feet. And so you're going to plug this in the same way we just did. Volume equals 4/3 pi r cubed. We'll put that 9 in for r, so we're going to have volume equals 4/3 pi 9 cubed. Put that in my calculator, 9 times 9 times 9, and I got 729 for that. Now, since they're asking us to find the exact value, I'm not going to multiply by pi. Remember, exact, which is in the directions you can't see, but you'll see in a minute. Exact means leave it in terms of pi. Don't multiply by pi. So what's going to end up happening is that here we're going to say 729 times 4, which I didn't write that in my paper, but it gives us like 7, 14, 28 something, 29 something. And then we divide it by 3. But when I divide it by 3, after I do 729 times 4 divided by 3, I get 486. And then I just take this pi and put it right here. So again, I took this 729 multiplied by 4 and then divided by 3, and that gave me 486. Then because I'm not multiplying by pi, I just bring pi down. And the last thing is just to make sure we put our units. This was in feet, so we'll put feet cubed, and that would be the volume as the exact value. If you wanted to find the decimal, you could then take 486, multiply it by the pi button in your calculator, and get that decimal. So again, here is what I wrote for that. Oh no, I made a mistake, y'all. Backtrack, 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 backtrack. Boop, boop. Pretend we didn't say any of that. Okay, so duh. I gave you the right answer, but just not the right way. Volume equals 4/3 pi 9 cubed. Wait, we already have 9 cubed on there. 729. Okay, pretend none of that happened. Okay, let's actually figure this out. Let's take 729. 729 times 4 gives me 2,916. Divide that by 3, we get 972. So my volume would equal 972 pi. Now, there's a reason that's not the right answer. Is this a whole sphere? No, that's a hemisphere. It's half of a sphere, meaning I need to take this number and divide it by 2 to get half of it. So when I divide 472 by 2, then I get the 486 pi that I was looking for. There we go. That's better. I just skipped this step and jumped right to here. So again, just be mindful if you have a hemisphere, you have to divide by 2 before you get your actual volume. Okay, so now you can pause it and copy this down. You can see that that's what I did. Sorry. Let's kind of do a couple adjustments here if you're copying from here. That should have been a 9. The rest of it's okay. All right, my last example on this is a bit of a word problem. It says, given a sphere with a great circle that has an area of 7.96 centimeters squared, find the volume. Use 3.14 for pi. So what that tells me is I have this sphere, and I have this great circle around the sphere, and the area of this great circle is 7.96. Well, the reason that we need to know the area of that great circle is the problem is if I go to try to do the volume, right? Volume equals 4/3 pi r cubed. I don't know what to plug in for r because all they gave me was that the area is 7.96. So I'm going to go over here and use the area formula. Well, we know the area of a circle is pi r squared. And if I know that the area is 7.96, I know to use 3.14 for pi. Well, then I can solve this equation, right? I would divide the left and the right side by 3.14. That causes that to cancel, so I have r squared left here. And when I divide 7.96 by 3.14, I get 2.54. So then I go ahead and just square root both sides, and the square root of 2.54, it was approximately 1.6. So now I know the radius is 1.6. I can come over here and plug that in. Volume equals 4/3 pi 1.6 cubed. And let's go ahead and type that in a calculator. I'm actually going to just do it with you. I think that's probably a better option instead of me just guessing and screwing up. So 1.6 to the third power is going to give me 4.096, which I can then times by pi, but they told me to use 3.14 in this case. And then I can times that by 4/3. So I'm going to times it by 4 and then divide it by 3. And I get 17.14 or 17 point. That's different than my notes. How did I get a different value in my notes? I know why I got a different value in my notes. Hold on. This is what happened on the notes. So I'm gonna just go ahead and show you what happens here in case you end up with the same confusion as I just caused here. If I take 7.96 and divide it by 3.14, we said it was approximately 2.54. But then if I square root that number, second square root, second answer equals, I get 1.5921, so I said it was approximately 1.6, right? But if I actually take that number and I put it to the third power, I get 4.036, which up here we had said was 4.096. So it's definitely a little bit off, right? 4.036 versus 4.096. So it's off by a little bit. So now I can take that value, times it by 3.14, times it by 4, divide it by 3, and I get 16.89, which rounds 16.9, which is what I actually have in my notes. So if you put 16.9 down as an answer, I would accept that. If you put 17.14 down, I would accept that too. I lost my pen. I lost my writing pen for this tool. There it is. So again, the volume that I had written down in the notes is 16.9, and then we would put, this was in centimeters, so I put centimeters cubed. Here's the truth. This answer is the most accurate answer because I didn't round in the middle of the problem. I solved it while using the numbers that I had. I didn't round. I rounded in the work that I showed, but I left all those numbers in my calculator. So 16.9 is definitely the more accurate number. If you got 17 point something, you're not doing it wrong necessarily, but you need to make sure you're mindful of that. That number can cause things to be off by a little bit, especially when you're doing like your IXLs and your quizzes. Make sure you're following whatever direction it says. Don't round until the end so that you can get those right answers. So again, let me bring this up here. This is where it starts getting real ugly. This over here should have been, I think the light was just hitting it wrong. 4/3 pi 1.6 cubed. This was centimeters cubed that I forgot to put, and then it's 16.9 centimeters cubed. So 16.9 centimeters cubed, if you can't see that. There you go. All right, so let me know if you need help. I'll be on my office hours this week, twice a day, 5 days a week. Come see me, come say hi, come check in. Best of luck. Let me know if you have any questions. Bye.